This video is going to briefly review statics and then focus primarily on free body diagrams. Okay, statics again is the study of forces and their effects on a system in a state of rest or in a state of uniform motion. As you should have gotten from watching the previous video, there's 3 laws of motion. To summarize, Newton's first law of motion, also known as the law of inertia, tells us that an object in a state of rest or uniform motion will continue to be so unless it's acted upon by another force. Newton's second law of motion, as a review, says that the acceleration of an object is proportional to the net force acting on the object and inversely proportional to the object's mass. It's summarized by the equation force equals mass times acceleration. Newton's third law of motion tells us that for every action force, there is an equal and opposite reaction force. That means that forces are always going to occur in pairs, and force pairs act in opposite directions, but they're always going to have the same magnitude. When we talk about statics, we need to talk about either scalar quantities or vector quantities. Let's focus on scalar quantities first. Scalar quantities are a physical quantity that has magnitude only. Okay, these are the things that you are probably most familiar with unless you've already studied vector quantities in another class. Some examples of scalar quantities include mass, length, time, volume, temperature, pressure, and speed. Again, so these would just have a value or a magnitude associated with them but no direction. So when we say it's 15 degrees outside, that's just a scalar quantity. A vector quantity, on the other hand, is something that has both a magnitude and direction. So position, velocity, force, and moments are all examples of vector quantities. So for example, I could say 15 meters to the right. That is an example of a position vector quantity. The right gives us the direction. If I say that we're going 55 miles per hour to the north, that's a velocity, and that's different than the speed of something. Okay, let's focus in just on what forces are. Okay, forces by definition means the pushing or pulling interaction of objects. A vector quantity defined by its known magnitude, direction, and point of application. Okay, so you can see the picture below. We've got a dog leash being pulled at 45 pounds. It's got a specific angle of 52.8 degrees northeast. Okay, so the 45 pounds is the magnitude, the 52.8 degrees is the direction, then the point of application would be where the chain is hooked to the dog's collar. Okay, so that's a way that we would represent a force. The British system of units is a pound of force, so the lbf is how you would see it abbreviated. The metric system is in newtons. Okay, and then we want to be able to convert between them, so there's your conversions below. 1 pound of force is the same thing as approximately 4.5 newtons. Or 1 newton of force is approximately equal to 0.2 pounds of force. In a nutshell, statics helps us to understand why things stay still. That's really important when we talk about a structure. We have to understand why things are balanced. When things are balanced, they tend to be in a state of equilibrium. That doesn't mean that no forces act on the body, it just means that the forces are balanced. The way that we know whether or not forces are balanced or not is through the use of a free body diagram. A free body diagram is just a visual representation of force and object interactions. The individual objects or members are isolated from their environment or system, illustrating all external forces acting on it. So if we were to draw a bridge, which would be like the one on the left, we get rid of anything else surrounding that bridge. The one in the middle could represent a pulley, so again we get rid of everything but the pulley itself. And then the one on the right could just be like a beam or a plank or anything like that. Okay, let's practice drawing a free body diagram. So here we've got a stack of 3 books, each weighing 5 pounds, sitting on a table. I want to draw the free body diagram of the top book, or the digital electronic books. This first step you need to do is sketch the isolated object. Okay, so the top book is what we want to draw. Typically we simplify the shape, so you can go like a rectangle, a square, or a circle. Okay, you don't have to draw in detail what the actual object looks like. The next thing that we want to do is sketch any forces that are applied and any normal forces that exist. A normal force by definition is just a support force. Okay, so when an object is in contact and is supported by a second object, it can be replaced by a normal force or the support force. Okay, it's always going to be perpendicular to the perpendicular to the surface of the second object. Okay, so we want to sketch the applied force and normal forces acting on that digital electronics book. All objects have weight, and whether or not we draw it on the free body diagram depends on how significant it is relative to other forces. When we deal with bridges, the weight of individual beams aren't significant, but for now, let's go ahead and include it in our free body diagram. Okay, the weight force vector is pointing down to the ground because we know that that's the direction that weight acts. The earth pulls all objects down towards them. We also have a normal force, and that's the reaction force pushing up on the book that's causing it not to fall. Again, that's a support force that we get from the fact that it's sitting on two other books and also the table. We want to label the objects and the forces. Okay, we know that the weight was 5 pounds because we were told that earlier. And then now I also know that my normal force is 5 pounds. I know that because the book's not falling. Those forces have to be balanced or they have to be in equilibrium. Let's try another example. I want to create a free body diagram for the children's sled pictured below. Okay, so again, we start out with just a simple shape representing the object. The weight of the object is typically one of the first forces we draw, so I'm going to draw that on my free body diagram as well. There's an applied force acting from the ropes of whoever is pulling them. Since it's at an angle, I keep it at an angle on my free body diagram as well. Notice that the angle is measured relative to the horizontal line. There's also a normal force that's causing the sled to not fall through the snow. Okay, the normal force again, is that support force that acts against the surface of the sled. There's a force of friction, that's what the F of F stands for, that's going opposite the direction of motion. Okay, so that is a complete free body diagram for the children's sled. Okay, let's try one for the refrigerator pictured below. Okay, the refrigerator is what we want. Notice how it's drawn at an angle relative to the surface. The weight of the object, though, still acts straight down. We still have a normal force or a support force applied by the ramp. It has to be perpendicular to our surface. There's a worker that's pushing the that's supplying an applied force up the ramp. And then there's also friction that goes against the direction of motion. Relative to that surface, there's our angle between our weight and our normal force. Let's try the pulley system below. Okay, I want to draw a free body diagram just of mass number 1. So there's my object, there's the weight of the object, and then there's a force due to tension acting upwards. Okay, there's only 2 forces acting on mass number 1. Let's draw the free body diagram of the movable pulley. Okay, there's our pulley. We have the weight of the pulley itself as well as the weight of mass number 2. Okay, all of those are acting down, so we're showing it as one vector. We have 2 tension forces acting upwards because we have 2 ropes supporting that pulley. Okay, we know that the tension forces are equal throughout the system, so the tension on the left would be equal to the tension on the right. Okay, now it's your turn. Okay, please pick up the packet from the sub and work through some review problems.